Now, if you will pay attention here, everyone, you will find that we have actually, in a way, reduced our problem, right? Reduced our problem, and that has actually been reduced in a similar manner. So initially I said that, hey, start from the full array and end towards the full length of the array and find an element X. But now what I have done is I have reduced my problem. I have reduced the size of my problem, where I am asking to just find in this particular part of the array or a list, right? So this is the whole understanding of course about the binary search. And if you have able to think like this, then doing it or changing it into recursion should be easy. So now let us see how exactly that's going to roll out. So the very first thing which you will find is that in binary search, I am just getting the list and the element to be found. We are not talking in terms of start and end. So for that, what we can do is we can create a helper function. Now this is again something which we have already discussed. So I can create a helper function. And in this helper function, now I am actually returning everything. Now I am just sending everything, right? So let me create this helper function. Great. L1, X, S and E, right? So the reason of course I have created this helper function is because I needed to send something more towards my argument, towards the parameters of my function. And I have already discussed that how we can do the same. One thing, always remember, more questions you do, more you will understand where you need to create this helper function. That's the first thing. Second thing is that yes, you could have created default arguments, but here it would have been a little difficult, right? You will have to create the length of L1, but we are making sure that we always send L1, right? We are not sending the copies of array. So L1 is going to change. So in this question, it would not have been possible, and we should be aware about this helper approach. This might seem a little bit difficult in initial few questions, but as and more you practice, this will become a lot more clear. Okay. Now, if I try to write my code for binary search, of course, first thing is if my S is greater than E, if my S is strictly greater than E, then I can return false. Because in this case, what is happening? In this case, what is happening is something like this. 1 second. That I am saying that my start is somewhere here and my end is here. Then of course this is not possible, right? If my start is here and end is here, I am actually in a way kind of giving you a negative size array, or the array of course is basically this is not a valid array, right? Valid list where starting is after the end. So that's why we can return false. Okay. The same thing we have actually seen I think in the iterative flow as well. Next is we have to find our middle. So middle we have already seen, we can find like this. So taking the float division, so small things, this is where it is used. Now if L1, and I think I missed one more thing, I missed this index. Now let's say, yeah, we can change that's the beauty of helper function, that we can take index here, right? Now M is there. Okay, sorry, my bad. We don't need to have this M. We have to find on not index. My bad. I got confused. We have to use an M only. And if this is equals to X, then I can return true. And now you have to pay attention. So earlier we were updating our small and end in iteration in this code only, right? In the for loop only. Now in this specifically, we are now sending S and E, the updated position in this particular function's parameter. So understanding is going to be the same, just that we are going to reduce our problem. So if my X is greater than middle element, then what should I do? So what I'm saying, let us take an example here. If let's say I'm trying to find 5 and this is 4, the middle is 4, right? As we can see here. Now, of course, 5 is something which is greater than 4. So I should found on the right side. To make sure that I'm founding on the right side, I should actually have my S, the starting element at middle plus 1. So what I'm going to do, I'm going to call this again. So I'm just going to do return binary search, and I should just make M plus 1. Right? I hope this is clear, everyone. Just I'm transforming the iterative understanding to recursion. And if that's not the case, like if that is not the case, then I can just do X. S can be as it is, but M is going to be now M minus 1. So for example, if I would have been finding 2 and the middle one is 4, now I know that, okay, this is the part where it's going to be, right? And I think that makes sense, right? I have to now remove or actually shrink my boundaries in this manner. So start is going to be at 1 only, but end is going to get shifted to 3, right? Again, all this have been done, but I'm still making sure that I explain you each and every step so you can understand These initial problems are a lot important to grasp the power and understanding of recursion. And I think this makes our code complete. Now, if you are thinking that why I didn't check else here with an else statement, the reason because I'm returning here, right? Because I'm returning here, this statement will only get executed when this is going to be false. So that's the reason I didn't check it like this, right? In each and every statement, I'm just returning directly. So it doesn't matter if I'm calling that afterward as well. So instead of this having this elif kind of a statement, I can just have it like this directly. Okay. And now I think this code will work. One second. Binary search using recursion takes 2 position argument. So this is something which we are calling here. We are passing the list and this, right? Let us see where the error is. And L1x 0 and length of L1. So where exactly it is giving the error? Let us see quickly, everyone. Binary search using recursion takes 2 positional argument, but 4 were given. Okay, my bad. I think I'm not calling it over. So we were actually calling this not the helper one. So 4 arguments were there, and it is only expecting 2, right? But we have to call this function only. Now it is able to say that okay, I'm able to find 5 here. Let's find 400. Let it update. 1 second. Let it save. So it's saying list index out of range. Okay, this is strange. Let us just quickly check where have we made an error. So it is m plus 1 and e, and this is okay. My bad. We have to send this length of L1 minus 1, right? That is something which you have to send. So I send the length, which of course is at the end. So somewhere the start is going to move towards end, and finally we are going to get list index out of range. That thing is very important. So always make sure that you first do this on paper or somewhere where you are writing your logic or understanding your logic and then transform it into code instead of directly jumping into the code. Now I made sure that this is what I'm taking as E. So the whole code is actually written with that in mind. Again, something which I explained you while we were doing iteration, right? So yeah, now I think this will work. Just one thing which I would like to show you, which I think all of you are anyway aware, but if let's say even our element is this big, even our list is this big, and let's say if I pass L1 here, we are not going to face any problem here because this is binary search. We have seen that how it is very fast, very much fast than your normal searching, right? The linear searching. So we are not going to get any problem, any error. In the module which will follow, we will be properly discussing about in terms that okay, why is this faster and about this time and space complexity of this particular function as well, right? So then you will be able to actually appreciate that okay, how powerful binary search as an algorithm is, and we can see the same here as well, right? So how quick it is, right? See, to find it. So great everyone, I hope the binary search again is now also clear. Please make sure that you understand these subtle helper things and how we are actually transforming the whole understanding into code. I never suggest to run behind solution. You can always write a solution by looking or by, I would say, understanding in gist. Like let's say you saw a video and writing it. The problem happens to understand and write it afterwards or after some time. So that is why I always make sense that I'm spending this particular time. Now what I will expect is that you are going to make a recursion tree for this and also run this particular code on Python tutor or try to basically make the visualization yourself as well so that your understanding is top notch. Okay, so now in the next video, let us focus on sorting algorithm which are specifically done using recursion, namely the merge and the quick sort. So I'm gonna again make sure that I explain you that properly, but before that, please make sure that you do practice on this particular code because the understanding is going to get used in that as well. Okay, cool then everyone, let's meet in the next video. Thank you.